Hello, today I'm going to do another amusing demonstration of the halo orbit of the James Webb Telescope. There's been a lot of interest in this halo orbit around the L2 point, so I decided to do a little demonstration using a large public fountain as a model for our solar system. And the results? Well, I'm not sure if it made anything more clear, but it does look pretty funny, and I had fun making this video. But first I'd like to start with a few easy-to-remember factoids. First of all, the telescope was inserted into L2 orbit on January 24th, 2022. Number 2, the moon is about 250,000 miles from Earth. Easy to remember. Where is the James Webb Telescope? Well, if you point to the sun with one hand and then point in the exact opposite direction with the other hand, the telescope is about 1,000,000 miles away in that direction, about 4 times the distance to the moon, but always in the opposite direction as where we see the sun, when we see it. Number 4, the mission was scheduled to last between 5 and 10 years, but NASA said that their launch was so efficient and they had to do so few course corrections that they figured that they extended the life of the mission from as little as 5 years to as long as 20 years. They have to stabilize its orbit by firing its thrusters about once a month to keep it from falling back or slipping away. Number 5. Now that the telescope is in its final orbit, it will begin the painstaking process of aligning the mirrors, and this process will not be complete until sometime this summer, so we won't see any images until this summer of 2022. Number 6, there are no cameras other than the telescope itself. Seriously? They couldn't fit one little webcam on there just so we can get some images of what's happening up there? Apparently the extra weight and the thermal noise of even one little camera they thought was not worth having it on board. So everything that we know about the telescope we're surmising from sensors that are not cameras. Number 7, cost. In round figures, it's about $10 billion over 24 years, most of which has already been spent. Just getting it off the ground and into orbit is most of the cost. Now I think they have less than $1 billion left to actually do the science. And number 8, the telescope was not designed to be serviced because, again, it's positioned about 4 times further away than any human has ever been. We've only been as far as the far side of the moon, and this telescope is about 4 times that distance. I do wonder if within 20 years we may come up with some sort of drone that we could send out there to fuel it up. It was not specifically designed to have that done, but it is technically possible. Okay, now that we have that out of the way, let's talk a little bit more about this so-called halo orbit around the L2 point. Several people have commented, and by the way, I love it when people leave comments. People have wondered in the comments what holds the James Webb Telescope in this halo orbit if there's actually no gravitational force at the center pulling it in, keeping it from flying off. And I admit that this is really counterintuitive, but if you look at the actual path of the telescope, you can see that the word orbit isn't really a good word for the halo component of its motion. It's really an up and down pattern around the sun, more of a wobble in its path around the sun than an orbit around the L2 point. Its path only looks circular from a moving frame of reference, a frame of reference that moves with the Earth around the sun. And to demonstrate that, I stepped into a large public fountain, thinking this would be a good way to demonstrate the actual path of the James Webb Telescope. And I don't know if it made it any more clear, but it's kind of amusing, so let's just take a look at it. For your amusement, here's L2 orbit around a fountain. I mounted a glowing ball on the end of a mop handle. The mop handle represents the gravitational attraction between the telescope and the Earth. I intended for the ball to represent the telescope, but it wasn't dark enough, so I went ahead and added the telescope in my editing software. Luckily, there isn't any water in the fountain during the winter, so I walked in a circle around the center and waved this telescope in a circular motion. So if I'm standing on the Earth, then the telescope appears to be moving in a more or less circular motion. But if we step back and look at it from another camera angle, we can see that the motion of the telescope is not circular at all. Its path is really more of a big wobbly path around the sun. Here are the two views together, along with a more accurate depiction of the situation along the bottom of the screen. I think this looks hilarious. While I was filming, a couple came up and asked what I was doing. Well, I started to explain about a telescope in the sky that was orbiting around a point that has no mass, and they sort of nodded their heads as if they understood what I was talking about, and then said, "Interesting. We'll just go stand way over here." Notice that in the image at the bottom of the screen, the telescope completes only 2 of these halo orbits in a full annual trip around the Sun. The halo orbit component has a period of 6 months. Well, I don't know if this demonstration of frames of reference helps understand a halo orbit, but as long as we're here, let's have some fun. Let's speed it up and add some appropriate music. Okay, thank you for watching. Don't forget to like and subscribe. And as always, cheers!